Hello, calculus fans. Let's talk about maximizing the directional derivative. Let's suppose that we have a function of 2 or 3 variables, and we think about all possible directional derivatives of f at a given point. So we've got the function f, we've got a particular point in mind, and now we consider all possible directions. And you have infinitely many directions that you could choose at a particular point to compute your directional derivative. The question is, which direction should we go in to have the largest possible directional derivative? So we're considering all possible directions. Which of these directions causes f to change the fastest? That is, which one causes us to have the largest directional derivative? And what is this maximum rate of change or maximum directional derivative? So the answers are given by this theorem. So the theorem says that if we have a differentiable function of more than one variable, then the maximum value of the directional derivative is simply the magnitude of the gradient vector, and the direction in which this occurs is when that unit vector has the same direction as the gradient vector. Let's prove this. We know that the directional derivative is simply equal to the gradient dotted with the unit vector. Let's go back to our definition of the dot product. That's simply going to be the length of the gradient of f times the length of u times cosine theta. And length of u is simply 1, so this is just length of del f cosine theta. Theta is the angle between del f and u. Notice I've started saying del f instead of gradient of f. I'm going to do this pretty consistently from now on. Del f is the gradient vector. Remember that the maximum value of cosine theta is 1, and that happens when theta is equal to 0. So we can say that the maximum value of the directional derivative is equal to the magnitude of del f, and it occurs when theta is equal to 0. Theta equals 0 happens when the unit vector in question has the same direction as del f. All right, as an example, let's suppose we have a function f of xy equals x squared of y plus 3x. Let's find the maximum rate of change of f at the point 5, 9 and the direction in which it occurs. First, let's compute the gradient of f at the point 5, 9. So del f is equal to y to the 1/2 plus 3, comma, 1/2 x y to the negative 1/2. So those are just the partial derivatives. If we plug in 5, 9, then we end up with the vector 6, 5, 6. That means we can say that the maximum directional derivative at 5, 9 is the magnitude of del f at 5, 9, which is going to be the square root of 36 plus 5 over 6 squared. And then the direction in which this maximum rate of change occurs is del f at 5, 9, which is equal to 6, 5, 6. And of course, if you were actually going to compute a directional derivative using this vector, you'd have to scale it down to a unit vector. But if we just want to talk about what direction to choose, it's okay to just say del f without scaling it down to a unit vector. Okay, that's all for now.